right, the second part of section 11.4 is called composite figures. And composite figures are figures that can be separated into regions that are basic figures, such as triangles, rectangles, trapezoids, circles, etc. So to find the area of composite figures, you need to find the area of each basic figure and then add all the areas together. Keep in mind that you can also be subtracting things off, so you can either add everything up or subtract off what you don't want. So examples, I'm not going to draw one because you're going to see examples all through this page. These are all called composite figures because they're made up of a bunch of figures put together. So let's look at an example of how to find the area of this composite figure. So when you look at this shape, you don't have anything on your formula sheet that says that weird shape has the area of so-and-so. You actually need to split it up into a bunch of figures. So what I do is I come up with a plan, Stan. I write down the areas of all the different figures I need, and then I just plug in all the information. Okay, so the first thing I'm going to do is I'm going to realize that to find the area, I'm going to need a semicircle, I'm going to need a triangle, and I'm going to need a rectangle. So that's my plan. I'm going to add these three figures together, and then I'll get the total area of the composite figure. Okay, so now I'm going to put my formulas in. My semicircle is pi r squared divided by 2, because I want half of a circle. My triangle is 1/2 base times height, and my rectangle is base times height. So I just need to find all three areas. I'll add them together, and I will be finished. Okay, so let's look at your semicircle. The area is pi, the radius is 4, squared divided by 2. So that's going to be what we get for the semicircle. The triangle is going to be 1/2 base times height. So the base and the height are going to be the legs of the right angle. One of them is 4, but I need this piece right here. So I'm going to do quickly the Pythagorean theorem to help me get the height of that triangle so the base and the height are perpendicular. So over here I'm going to set up 4 squared plus x squared equals 5.7 squared, and that's going to give me the height of the triangle. Okay, so I'm going to tell you what you get when you solve the Pythagorean theorem, because you know how to do that. You're going to get a 4.1, and that is going to be the height of that triangle, or the base, so that the 4 and the 4.1 are perpendicular. So your base is going to be 4, and your height is 4.1 by using the Pythagorean theorem. Plus my rectangle. Okay, my rectangle has a base of 4 and a height of 7, or vice versa. It doesn't matter, but you have a 4 times 7. Now, all I'm going to do is I'm going to add up all of these things. I am going to multiply pi out, and I'm going to get a total answer. So I just start typing in my calculator. You can do them individually and then add them, or you can try to type them in all at once if you're very careful. So if you try to type all these in, eventually you're going to get an answer of about 61.3 square feet. So it really is everything that we've been doing up to this point. You're just adding all of the pieces together. Okay? So let's look at a couple more composite figures so you can get the idea of how to get it set up, and then you'll be able to type it in to get the area. Okay, so there is nothing on our formula sheet that says weird figure that looks like this. There's no formula for that. So you're going to have to turn it into something that you can make a formula for. So you can divide this a couple ways. You can divide it horizontally, or I actually divided it vertically like this, and I created a rectangle and a trapezoid. So that's what I'm going to use for my plan. So my plan is rectangle plus trap. So if you have your formula sheet handy, then you'll be able to plug these formulas in. Okay, so the formula for a rectangle is BH. The formula for trapezoid is 1/2 times height times the sum of the bases. And you can get those from your formula sheet, and you're just going to write them down. Now we're going to fill in all of the blanks. Okay, for my rectangle, the area is 12 times 8, base times height. For my trapezoid, now you have to remember your trapezoid is sideways. The height is actually this piece right here. That's your height, because that's what's perpendicular to the parallel bases. So we got to find that. So notice if this piece is 8, then this piece right here for the height is 15 minus 8. So you have to subtract. 15 minus 8 is 7 inches. That makes the height 7. And then we need the sum of the bases. Okay, this base is 5, and then this base would be the same as this side of the rectangle. So that one would be 12, just like this side is 12. So 5 plus 12. All right, so you would do 12 times 8, and you would get that area is 96. And then when you type in half of 7 times 17, you should get 59.5. And then we just add those together to get the total area. So it's like finding the two separately and then adding them together. So you're going to get about 155.5 inches squared. Okay, we're going to do one more quick example over here, and then we'll do one on the back page, and we'll be finished with this. So this is a weird figure. It's called a composite figure because it's multiple figures put together. So when you look at this figure and you cover up this semicircle, you see a trapezoid. So this is a trapezoid plus a semicircle. So that's the plan. So the area is trap plus semicircle. Now we're going to go to our formula sheets, and we're going to write down the formulas for each. So there's my trapezoid, and then my semicircle will be pi r squared, but I'll just divide it by 2. So pi r squared's there, we'll just divide it by 2. So area equals 1/2 height, base 1 plus base 2, plus pi r squared divided by 2. For the kids that write the formulas down, usually they get them right every time. If you don't write the formulas, usually you miss something little. Okay, so let's put stuff in here. Area is 1/2. Now, the height, we got to find this. So what's going to happen is we are going to have to come over here and use this triangle to get our height. Okay, so if from here to here is 31, we're going to be doing 31 minus 22 to get 9 right here for this piece, because this whole thing is 31, but this part's 22, so that makes this 9. Okay, so we're going to do Pythagorean theorem with this right triangle by setting up 15 squared equals 9 squared plus x squared. All right, if you solve that, which you will already know how to do, you will get a 12. So that makes the height of the triangle, the height of the trapezoid, 12, which is also the height of the triangle. So that's 12. Now we need the bases of the trapezoid. So the top base is 22, and the bottom is 31. Now we're going to add on the semicircle, pi r squared. All right, well the 12 I just found is also the diameter of my circle. So I'm going to divide that 12 in half, and I'm going to use a 6 for my radius. So it's going to be pi 6 squared, and then I'm going to divide that by 2. All right, so we're going to type in the trapezoid numbers. We're going to type in the semicircle numbers. You can do them separately or all together. Just be careful if you do it all together. And then we're going to add them. So half of 12 is 6. So you can take 6 times, that's going to be 51. 6 times 51 will give you the trapezoid. And then go ahead and type in pi. Pi 36 divided by 2. And when you add everything up, you should get a grand total of about 374.5 centimeters squared. So again, it's called a composite figure because you're just adding multiple figures together. Occasionally you got to use Pythagorean theorem or specials to help you. All right, this one you guys are going to come back and do after the video and check your answer, but I'm going to show you one more question on the back. You will skip this one, and here's the last one. We're not looking at 11.5, we're just going to do this one. So this is on the top of 88, it'll be the last question. Okay, to get the area of your parallelogram, do you guys see how there is a kite inside that we need to take out? So we've got to do the parallelogram, but we're going to minus the kite off. Instead of adding something, we're going to subtract it. So the area is going to be a parallelogram minus a kite. So keep in mind, that's the plan, Stan. You got to take the parallelogram, take the kite out. Okay, let's write the formulas. So you go to your blue formula sheet. Parallelogram is base times height. Kite is 1/2 diagonal 1 times diagonal 2. Okay, so base times height minus 1/2 diagonal 1 times diagonal 2. All right, so the base and the height of the parallelogram. Well, the base is 14, and they showed you that this 9 is perpendicular to this 14. So that's the base and the height. They're already perpendicular to each other. And now we're going to take off the kite pieces. Okay, so the kite pieces, if you look, this diagonal right here matches the length of the side at the top of the parallelogram. So that is 14. So that's 1/2 of 14. And then the other diagonal that goes this way matches the height of the parallelogram. So that's going to be 9 for this one. So you already know your two diagonals. So now we're going to find the parallelogram and subtract out the white kite that we don't want there, and what will be left will be the shaded region. Okay, so 14 times 9 is 126. Take off the 1/2, 14 times 9, which is 63. And your final area is going to be 63 square feet. So occasionally you might have to use subtraction instead of addition, and that would be an example where you take something out instead of adding it on. Okay, you will go back and try this question here and check your answer on Canvas.